Hi everyone. In this video, I would like to explain the implementation of Boolean operations in graphs in TopologicPy. So what are Boolean operations? Regular Boolean operations are logical operations that combine or modify sets, shapes, or conditions based on binary logic. For example, a union and merge combines all elements from both sets. Intersection finds the common elements in both sets. Difference removes elements of one set from another, and symmetric difference or exclusive OR removes the elements that are common to both sets and combines only the elements that are not common to both sets. There are two irregular Boolean operations that we have implemented in TopologicPy, and you'll see them later visually. That will explain them a little bit better. But basically, they're called impose and imprint. So impose combines all elements from both sets and replaces the common elements with the corresponding elements from the imposed set. And you would say, for example, what's the difference because they are the same elements? In TopologicPy, in graphs, we are replacing the dictionaries of the vertices that are common. So while the vertices might be the same, or the nodes might be the same, their dictionaries might not be, so you replace one with the other. That's the kind of concept of imposing here. And imprint is similar, but it replaces the common elements in the first set with the corresponding elements in the second set. So things that are not common are not imposed, they're just imprinted. So only the common elements are replaced. And the term Boolean, just for your information if you don't know, comes from George Boole, a 19th century English mathematician who developed Boolean algebra, the foundation of modern digital logic and set theory. So how are Boolean operations applied to graphs in TopologicPy? So graphs in TopologicPy, as you know, are made of vertices or nodes and edges, which are usually relationships. The Boolean operations operate mainly on the vertices of two graphs. So two vertices are deemed to be the same if one or more user-specified dictionary key values are equal. And two edges are deemed to be the same if their start and end vertices in no order are the same. So what graph Boolean operations are available in TopologicPy? We already hinted at that. We have 6 methods. One is called union or merge. You can find both names there. Intersect, difference, which is subtraction, and symmetric difference or exclusive or XOR, and those two names are also available as function names, as well as impose and imprint. So here is a visual example. We have graph A and graph B. So graph A is basically a subset of graph B with an additional red vertex. So if you can kind of visually match one corner, let's say you can take on the right side corner of graph B, and you can imagine graph A with the orange nodes being that graph. So it is a subgraph, it's a portion of it. I took a portion of it, and then I added an additional vertex red that is not found in B. So here is the result of a union or a merge. So basically in the upper right corner, just to remind you of graph A and graph B. So when you do A plus B, of course, topologically, A plus B is the same or identical to B plus A. However, as you can see here, the visual result might look different to you, depending on whether you place A or B in the beginning, at the start of the function. The order changes the visual result, but not the topological result. Why does this happen? Basically, when you say A plus B and A comes first, the common vertices stay where they are. So you can imagine that these brown vertices used to be the orange vertices in graph A, and brown is basically the addition of the purple and the orange, and they stay in the XYZ coordinates of the original A graph. On the right side, you'll notice that B plus A, the vertices that are in B stay where they are, but they get replaced by, of course, brown vertices because of the addition of the color. And the red vertex, because it's not common, stays where it is. So you have a connection all the way back to the red vertex. I hope that this is clear. Try it out. There is a Jupyter notebook on GitHub that has this example, and you can test it and see what it gives you. Now the intersection is, again, topologically the same. So you can see here, it's all these brown vertices. It's the subgraph of B that has made graph A without the red vertex. But actually, if you draw these two graphs, A times B and B times A, the A times B will be located where graph A is located, and B times A would be located where graph B is located. So they would have changed X, Y, Z coordinates, but topologically they are the same. In terms of difference, again, A minus B gives you only a graph with a single vertex and no edges, so that's the red vertex. And B minus A removes A from B, so you get less purple vertices. The symmetric difference, or exclusive OR, are the nodes in A and B that are not common. So in graph A, it's only the red vertex, and in graph B, it's the purple vertices that are not common. And the resulting graph would be what you see here. This is actually one graph with an isolated vertex. Now, impose, again, what you impose is the order of imposition is important. So if I am imposing B on A, as you can see here on the left side, all the vertices of B stay exactly the same, but the ones that are common, they basically connect to the ones that are not common. So basically you're imposing, but you are also establishing the correct relationships. So you'll notice that the very small vertex here is connected back to red because this small vertex matched this vertex here, and the relationship is now established. However, because it is imposed, all the graphs of B, which are still there, by the way, it's not that they have been deleted, but they are actually replaced by the purple vertices. Now, when you impose A on B, basically all the orange vertices stay where they are, and they are removed from B. As you can see here, they're gone, but the relationships are, of course, still maintained. And then also the red vertex is added to the mix. So now we have a new graph that is, of A imposed on B. Now, imprint, basically, it's almost like putting a stamp. So you basically imprint only the common vertices, and the ones that are not common are omitted. So as you can see here, when we impose B on A, we take the ones that are available here, that are common, the purple ones, and they replace, they replace the ones in A, and of course the red vertex stays as it is because it's just imprinted. It does not remove it. Now when we imprint A on B, we take all of this. Imagine taking this graph A, the orange one, and placing it here and just finding out what is common. So the red is omitted, and then the purple vertices that are common are replaced with orange vertices. So this is the imprint function. As I said, there is a Jupyter notebook called Graph Booleans on GitHub, and please consult that for more information. And if you have any questions, please don't hesitate to contact me. Thank you for listening.